It's the year 2100. Humanity has successfully expanded beyond Earth, living on the Moon, Mars, and even harvesting resources from asteroids. But how did we get here? How did we go from being a species that could barely make it to the Moon, to one that's now mining asteroids and setting up colonies on other planets? Well, to understand that, we need to rewind a bit and take a look at where we stand today. Now, space exploration isn't some far-off fantasy anymore. We've already sent probes to the outer edges of our solar system, and private companies are sending rockets to space like it's no big deal. But here's the thing. While space is full of possibilities, it's also full of challenges. You see, space isn't just about the adventure of discovery. There's a deeper, more urgent reason we're looking beyond our planet. Resources. Earth's resources are getting depleted, and we're facing environmental crises that threaten our way of life. The need for space resources is no longer a maybe. It's a must. We're talking about water, minerals, and energy, things that could help power humanity's future, both here on Earth and on other planets. But here's the real kicker. This isn't just a futuristic dream. The groundwork is already being laid. Companies are already planning to mine asteroids for precious metals and rare elements. Governments are looking at the Moon and Mars as potential hubs for resources that could sustain life beyond Earth. And it's all happening faster than we ever expected. So, buckle up, because we're about to take a journey into the future where space exploration isn't just about finding new planets, it's about finding the resources we need to survive, thrive, and maybe, just maybe, save our planet from disaster. Stick with me as we dive into this quest for space resources and see what the future holds for us in the vast, limitless expanse of space. Because trust me, the next 100 years are going to be wild. Okay, let's rewind a little. Before we even thought about mining asteroids or setting up shop on Mars, we had to get our feet wet in space. And by that, I mean we had to take those first steps out into the great unknown. Remember the 1960s? That was the time when the world's eyes were glued to the sky, watching as astronauts raced to be the first to break Earth's atmosphere. The space race wasn't just about science, it was about proving power. It was the Cold War after all, and getting to the Moon was more than just a scientific milestone. It was a matter of national pride. But let's not get too stuck in history. Sure, the Apollo mission was a huge deal. It landed humans on the Moon for the first time in 1969, and that was a game changer, right? But beyond the flags and footprints, there was something bigger happening. That moon landing wasn't just a look what we did moment. It was the start of something much more profound. Space exploration was real, it was tangible, it wasn't just a dream anymore. Fast forward a little, and the focus began to shift. The early missions were about getting there, getting to the Moon, getting to Mars, and just exploring. But after we hit that major milestone, the next question became, what can we actually do with space? And it's not just about curiosity anymore, it's about resources, materials that can be used for technological advancements and, honestly, saving our planet. By the late 20th century, we weren't just building rockets, we were building the infrastructure needed to access space regularly. Satellites were launched to provide communication, navigation, weather predictions, and more. All of a sudden, space wasn't just for the elite, it became a new frontier for global cooperation and advancement. Governments and organizations like NASA were working with private companies to expand the boundaries of what was possible. And while that was happening, a whole new idea was starting to take shape. What if we could get something useful from space, not just knowledge? That's where the idea of space resources really started to take off. The first hints of this came with things like asteroid mining. Tiny asteroids flying around in the vastness of space, filled with precious metals and minerals. Sounds crazy, right? But think about it for a second. The Earth's resources were being depleted, and some of those metals, things like platinum, gold, even water, could be found in abundance out there in the cosmos. It seemed almost too good to be true, but the early pioneers saw the potential. By the early 2000s, space agencies and tech companies started looking at space resources like never before. And that's where things really got interesting. The notion of space mining was no longer the stuff of science fiction. Suddenly, companies like Planetary Resources and Deep Space Industries were talking seriously about extracting materials from asteroids. They were laying the groundwork for what would eventually become a multi-billion-dollar industry. So, here's the question: how did we go from a few brave astronauts landing on the moon to an entire industry focused on harvesting space for resources? Well, it's the story of a lot of experimentation, technological innovation, and, honestly, a little bit of luck. We had to solve a whole bunch of problems: how to get to space safely, how to land on asteroids, how to mine in a zero-gravity environment, all things we couldn't even imagine back in the 1960s. But one thing was clear: once we got started, there was no turning back. Now let's talk about the turning point, the moment when space exploration stopped being just about the wow factor and started being about something more practical, something necessary. And that's when we started realizing Earth's resources weren't going to last forever. The early days of space exploration were cool, sure, but they were also about a sense of adventure. We were all looking up at the stars thinking, one day, we'll figure out how to live out there. But by the mid-21st century, we started facing the harsh reality that our planet was in serious trouble. Overpopulation, climate change, resource depletion, the writing was on the wall. Now, don't get me wrong, Earth is still an incredible place to live. But the fact is, our natural resources were being drained faster than we could replenish them. And we were starting to notice the cracks in the system. Water shortages, energy crises, the destruction of ecosystems, all of these issues started stacking up. By the 2040s, it became clear that if humanity wanted a shot at long-term survival, we were going to need to look beyond our planet for help. And that's where space came in. Space isn't just this endless void anymore, it became the new frontier for resources. Think about it, asteroids are floating around with vast amounts of metals, water, even rare earth elements. These aren't just nice-to-haves, they're things we need, and that was the breakthrough moment. Well, in the 2040s, advancements in robotics, AI, and autonomous systems really started to change the game. Space was no longer just a place for astronauts. It became a place for machines, drones, and robots to operate 24/7, mining resources without the risks humans would face. These technological breakthroughs weren't just about making space travel cheaper or faster, they were about making it viable to actually extract materials. It became clear that this was no longer a far-off dream, it was a necessity. The idea of space mining moved from something in science fiction to something companies were actively planning for. On top of that, we saw major global players in space exploration start to make real moves. The US, China, the European Union, they were all on board, not just for exploration, but for securing resources that Earth simply couldn't provide anymore. Governments started to pour money into space resource projects, which gave rise to private corporations eager to stake their claims in this new economy. Space became the new gold rush. But, and this is key, it wasn't just about mining precious metals like gold or platinum. No, it was about water. Water is one of the most essential resources, not just for life on Earth but for sustaining human colonies on the Moon or Mars. And that's where places like the Moon and even certain asteroids became incredibly valuable. Imagine harvesting water from the Moon's polar ice caps, using that to fuel spacecraft, or even to support a human colony there. This wasn't just about technology, it was about saving humanity from an uncertain future. By the 2050s, the race was on. Companies like SpaceX, Blue Origin, and others were already setting their sights on lunar mining operations. They weren't just thinking about the Moon as a place to land humans, they were thinking about it as a resource base. And those first lunar water harvests, they were the stepping stones to something much bigger. So, while space exploration had always been driven by the curiosity of looking up at the stars, by the 2050s, it became something driven by necessity, survival. As we hit the 2060s, the conversation wasn't about should we go to space anymore, it was about how soon can we start, and more importantly, how soon can we get our hands on those resources. Alright, now let's talk about the players. The countries, companies, and organizations that saw the potential in space resources and dove right in. This is where things get really interesting because the race for space resources wasn't just between countries like we saw during the space race. No, this time, private companies got in on the action, and things got even more competitive. Let's start with the big nations first: the United States, China, Russia, and the European Union. These countries have been at the forefront of space exploration for decades, but as the stakes got higher, they began to shift their focus. The United States government, with its long history of space exploration through NASA, wasn't about to let space resources slip through its fingers. By the 2050s, NASA's goals expanded beyond just sending people to the Moon or Mars. Now, it was about securing resources, making sure the United States had access to those materials before anyone else did. China, on the other hand, was also playing the long game. They had made huge strides in space exploration, especially in the 2040s and 2050s with their ambitious lunar and Mars programs. But China didn't just want to land on the Moon. They wanted to control the resources there. Water, metals, rare earth elements, you name it. The Chinese government poured billions into its space programs, with a focus on building the infrastructure for mining operations. They saw the writing on the wall: securing space resources was going to be key to their future power. Then there's Russia. Historically a major player in space, but by the 2060s, Russia had started focusing more on partnerships rather than leading the charge alone. They knew they couldn't compete with the likes of China and the United States on their own, so they shifted towards collaborative missions, especially with the European Union and smaller nations. Russia's expertise in space technology and its early successes with lunar missions made them a valuable partner for future space mining efforts. They weren't going to let China and the United States get all the action, but they knew that working together would benefit everyone. And let's not forget about the European Union. While not as fast-paced in its race for resources, the EU's approach was methodical and heavily focused on international cooperation. They prioritized creating legal frameworks for resource sharing, ensuring that space didn't become the next Wild West. They wanted to make sure that the extraction of resources from asteroids, the Moon, or Mars benefited all of humanity, not just the few nations with the most powerful space programs. But here's the twist. Enter the private companies. By the late 2050s and early 2060s, companies like SpaceX, Blue Origin, and even new players like Asteroids and Planetary Resources were staking their claims in space resource mining. These weren't just small startups anymore. These were multi-billion-dollar companies with massive infrastructure and resources. They had the technology to launch spacecraft, land on asteroids, and mine them for precious metals and water. SpaceX, led by Elon Musk, wasn't just looking at Mars as the destination for human colonization. They saw Mars as a potential treasure trove of resources, and they wanted to make sure they were the ones to get there first. Blue Origin, with Jeff Bezos' vision, wasn't far behind. Their goal was to make space more accessible, and with their plans for lunar mining, they were positioning themselves as key players in the resource race. It wasn't just about the big names, though. Smaller companies began to emerge, all with their own unique approaches to space mining. Some focused on asteroid mining, while others aimed at building infrastructure in orbit to gather resources from asteroids and the Moon before transporting them back to Earth, or using them for deep space missions. These companies didn't just want to participate in the space economy, they wanted to dominate it. And it wasn't just about making money either. These companies understood that space mining had the potential to solve some of Earth's biggest problems. Water from the Moon could help sustain colonies on Mars, and precious metals from asteroids could alleviate shortages of these materials on Earth. This wasn't just about corporate greed, it was about building a future that was sustainable, with the potential to solve the resource crises here at home. So, it's safe to say that by the year 2100, space was no longer just about nations racing to claim their stake in the stars. The competition had expanded to include private companies, each vying for a piece of the multi-trillion-dollar space resource industry. Whether it was national governments or private enterprises, everyone knew one thing for sure: if you wanted to secure the future, you had to stake your claim in space. So now that we've got a sense of who's involved, let's zoom in on the targets, the places in space that are at the heart of the resource race. We're talking about asteroids, the Moon, and Mars. Each of these celestial bodies holds immense potential for resources that could completely change how we live. not just on Earth but in space too. Let's start with the low-hanging fruit, asteroids. Asteroids are the real game changers. These little rocky bodies floating out there in space are full of valuable materials, things like water, rare earth elements, platinum, and nickel. These materials are crucial for technology, energy, and even for life support systems. And here's the kicker: a single asteroid could contain more precious metals than all the gold mined on Earth in history. Imagine that. Just one asteroid with enough resources to power entire industries for centuries. But here's the tricky part. Getting to these asteroids isn't like flying to the moon. The orbits are unpredictable, and their distances can range from just a few million kilometers to hundreds of millions. Still, thanks to advancements in propulsion technology, missions to asteroids became more feasible by the 2050s, and by the 2060s, asteroid mining started looking like a reality. Companies started developing new spacecraft designed specifically for asteroid retrieval, with robotic mining tools and automated systems to extract and process resources directly in space. The idea was to extract the materials and send them back to Earth, or better yet, use them to fuel deeper space exploration. Now let's talk about the moon, our nearest neighbor in space. When people first looked at the moon, it was all about landing there, planting flags, and taking some incredible photos. But now, the moon is seen as a major resource hub. The real gold mine on the moon isn't just the surface, it's what's hidden in the polar regions, specifically water ice. That's right, water. The moon's south pole is believed to have vast deposits of frozen water that could be used not just for drinking, but for creating hydrogen and oxygen, key ingredients for rocket fuel. So, in a way, the moon is becoming a launch pad for the next stage of space exploration, where water mined from the moon could fuel missions to Mars and beyond. Lunar mining has become a priority for multiple countries and private companies, with missions already planned to extract and process this water ice. But beyond water, the moon also has something else that's incredibly valuable: helium-3. This is a rare isotope that could potentially be used as fuel for nuclear fusion. Fusion is the holy grail of energy production here on Earth: clean, virtually limitless energy. So imagine if the moon was the key to solving Earth's energy crisis. It's no wonder that the moon is now a target for so many players in the space resource race. But of course, we can't forget about Mars. Mars has always been the big dream. It's been the target of manned missions for decades, and by 2100, it's expected that humanity will have established permanent settlements there. But here's the thing. Mars isn't just a place for colonists. It's also home to a wealth of resources that could make it a self-sustaining colony. Mars has water in its polar ice caps, which is a huge resource for future settlers. But there's more. Mars is rich in minerals, including iron, nickel, and even sulfur. These materials could be used for building infrastructure on Mars and supporting life, without needing to ship everything from Earth. And here's the kicker. Mars also has vast amounts of carbon dioxide in its atmosphere. Sounds like a problem, right? But actually, that CO2 could be used to create oxygen for breathing and fuel for rockets. So Mars isn't just a destination for humanity. It's a resource base that could help us survive and thrive. Companies and governments alike are already working on the technologies needed to extract these resources efficiently. By the 2070s, mining operations on Mars could be in full swing, making it an invaluable part of humanity's space resource network. So, whether we're talking about asteroids, the moon, or Mars, each target is more than just a place to explore. These celestial bodies are rich with resources that could change everything. Whether it's solving Earth's resource crisis, building self-sustaining colonies in space, or fueling the next big wave of space exploration, each one offers something unique, and by 2100, humanity's resource network will likely span all of them. Alright, now we're talking about the real backbone of the space resource revolution, the technology. Without the right tools and innovations, all this talk about mining asteroids and colonizing Mars would just be that. Talk. But thanks to decades of progress, we're starting to see real technology that can make these dreams a reality. And trust me, this stuff is fascinating. First off, let's talk about space travel. Getting to space is no longer the massive, expensive feat it used to be. Remember when it took billions of dollars and huge government agencies just to launch a single rocket? Well, things have changed. Private companies like SpaceX and Blue Origin have driven down the cost of launching payloads into space, and with reusable rockets, they've turned space travel into something more like a regular business. By 2100, rockets that used to cost tens of millions of dollars per launch now cost a fraction of that. This breakthrough was one of the key turning points in making space resources accessible. If it costs too much to get there, no one's going to bother mining. But with cheaper, more efficient launches, space resources suddenly become within reach. Then there's the propulsion technology. To get to an asteroid, the moon, or Mars, you need more than just a rocket that gets you off the ground. You need something that can get you there and back. And that's where things like ion thrusters and nuclear-powered propulsion systems come in. Traditional chemical rockets are great for launching, but once you're in space, you need something more efficient to travel long distances. Ion thrusters use electricity to create a super-efficient propellant system that can keep a spacecraft in motion for years without running out of fuel. And nuclear propulsion? That's even more of a game-changer. By using nuclear reactions, we could power spacecraft for much longer missions, dramatically cutting down travel times to distant asteroids or Mars. This kind of propulsion technology opens up the entire solar system for resource exploration. Now let's talk about the tools we'll need to actually mine these resources. Space mining is a totally different ballgame compared to traditional mining on Earth. You're not just digging into the ground, you're in zero gravity, on the surface of an asteroid or the moon with very little atmosphere to protect you. This is where robotics come into play. Robotic mining systems are already being developed to work autonomously, with zero human intervention. Think of machines designed to scan asteroids for valuable resources, extract them, and process them, all while floating in space. These robots need to be built to withstand the harsh conditions of space, with high-tech sensors and AI systems to analyze and identify the best materials to extract. They also need to be able to repair themselves since there's no quick trip to a mechanic out there. What's even cooler is that these robots are designed to work together in fleets. It's not just one robot going solo. It's a team of autonomous machines working in harmony, collecting materials, sorting them, and sending the data back to Earth in real time. And, as AI continues to advance, these systems are becoming more efficient and capable of performing complex tasks without direct human control. Now, on to something a little more futuristic: 3D printing and manufacturing in space. This could be the key to making space resource mining truly sustainable. Instead of shipping materials from Earth to build the equipment or infrastructure needed on the Moon or Mars, we could 3D print everything on site. Imagine building entire mining colonies on the Moon using nothing but materials pulled directly from the lunar surface. 3D printers would use lunar regolith, or moon dirt, to create building materials, tools, and even machinery. This not only makes space mining more cost-effective, but it also makes it more sustainable. If you can build everything you need using resources already found in space, you reduce the need for supply runs from Earth, which is a massive logistical and financial hurdle. Of course, we also have to think about communication and data transfer. In a world where space operations are spread across millions of kilometers, maintaining a reliable connection back to Earth is crucial. With advancements in quantum communication and laser-based technologies, we're now able to send data faster and more securely than ever before. This means that when a robot on an asteroid or the Moon finds a valuable resource, the information gets sent back to Earth nearly instantaneously, so decisions can be made in real time. The efficiency of space mining operations is directly tied to how well we can communicate with these far-off locations. And don't even get me started on artificial intelligence. AI is going to play a huge role in managing space mining operations. From resource extraction to sorting, processing, and even predicting which asteroids are worth mining, AI will handle most of the decision-making. It'll analyze vast amounts of data and make critical decisions faster than any human team could. It'll also manage the autonomous fleet of robots working on site, ensuring everything runs smoothly without needing a human to step in. Finally, let's touch on sustainability. When we talk about space resources, it's not just about getting raw materials back to Earth. It's about using those resources in space itself. Whether it's for fuel, oxygen, or building materials, we need to make sure we're not just taking from space, but also using those resources to support the expanding human presence in space. If we can mine asteroids for water and use it to fuel our rockets, we won't need to rely on Earth-based supplies anymore. If we can mine Mars for metals and use them to build habitats, then we've created the foundation for permanent settlements off Earth. The key to making all of this work is creating a fully self-sustaining cycle, where resources aren't just extracted but also recycled and reused. It's these technologies, the rockets, the robots, the AI, the 3D printers, and the communication systems, that are all coming together to make the dream of space resource mining a reality. Without them, we'd still be stuck in the idea phase. But, thanks to some incredible breakthroughs, humanity is now on the verge of tapping into a whole new frontier of resources, not just on Earth, but across the solar system. Now, I know what you're thinking. All this talk about space mining and resources sounds great, but what about the rules? Who owns space? Who gets to say, this asteroid is mine, or that water on the moon belongs to me? Well, let's dive into the messy side of space, where law, ethics, and international cooperation come into play. The thing is, space doesn't have any clear boundaries like Earth does. We're not dealing with countries and territories in space. So who owns these resources? Who gets the profits from mining a distant asteroid? These questions are at the heart of the debate surrounding space resource exploitation. The last thing anyone wants is for space to turn into a Wild West scenario where countries and corporations are duking it out for ownership of asteroids, planets, and the moon. Historically, space law has been shaped by treaties like the Outer Space Treaty of 1967, which is basically the cornerstone of international space law. This treaty says that space is free for exploration, and no nation can claim sovereignty over any celestial body. It also says that space should be used for peaceful purposes and that the exploration of space should benefit all of humanity. Sounds good, right? But here's the catch. While the Outer Space Treaty prohibits nations from claiming ownership of celestial bodies, it doesn't really address resource extraction. It was written at a time when space was about exploration, not resource mining. So, there's a huge gap in the law when it comes to how we can use the resources we find in space. To fill that gap, some countries have started to make their own laws. For example, the United States passed the Space Act of 2015, which essentially allows US companies to claim ownership of the resources they extract from asteroids and the moon. Other countries like Luxembourg and the UAE have followed suit with their own space resource laws. These laws allow private companies to mine space, but the question remains, are these national laws enough to govern a space that's meant to belong to all of humanity? This is where things get tricky. If a US company goes to an asteroid, mines it for precious metals, and brings those materials back to Earth, who gets to decide whether that's okay? If the US says it's fine but another country disagrees, we have a potential conflict on our hands. The Outer Space Treaty says space resources should be used for the benefit of all, but there's no real enforcement mechanism. So we're left with this gray area where countries are trying to figure out how to regulate what's essentially a global resource. Some people think that space resources should be shared among all nations, while others argue that whoever extracts the resources should own them. It's a classic case of competing interests. Ethically, the situation gets even more complicated. If private corporations are the ones doing most of the space mining, is it fair for them to claim ownership of resources that were once thought to be the property of all humankind? After all, we're talking about things that could be key to the survival of future generations: water, energy, and essential materials. If a company claims the rights to resources that could help support life on Mars, does that mean only they get to decide who gets access to it? What if they sell it to the highest bidder, and only the wealthiest nations or corporations have the means to use these resources? This brings up huge questions about fairness and equity. Not to mention, there's the issue of environmental ethics, or rather, the lack of it. What happens if we start mining these celestial bodies and cause irreparable damage? If we strip an asteroid of all its resources, do we disrupt its orbit or change its trajectory in a way that affects the entire solar system? What about the moon? If we mine its water, could that alter its role in stabilizing Earth's tides or affect its gravitational pull? Sure, these might sound like sci-fi worries, but they're real concerns for the people working on space mining projects. If we're going to start extracting resources, we need to do it responsibly. Just like we need to consider sustainability here on Earth, we'll need to think about sustainability in space. Then there's the question of space debris. As we send more and more missions to extract resources, the risk of creating space junk goes up. We've already seen the mess in low Earth orbit with satellites and other debris piling up, so the question becomes, how do we make sure we don't leave a similar mess in space? If we start mining asteroids and the moon, we're likely to leave behind remnants of equipment, broken spacecraft, and other debris. It's not just a practical issue, it's also a legal and ethical one. Who's responsible for cleaning up? Will there be an international body that oversees this process? Or will it fall on individual companies to make sure they don't pollute the space environment? There's a lot to think about here, especially as more and more countries and private companies get involved in space mining. And lastly, we can't ignore the issue of space militarization. With all this competition for resources, what's stopping nations from turning space into the next battlefield? The more valuable space resources become, the more likely it is that countries will try to secure their stake, possibly with military force. That's a scary thought, but it's one that's been raised by experts in the field. While the Outer Space Treaty prohibits the deployment of weapons of mass destruction in space, there's nothing stopping countries from using space for strategic military purposes. If it comes down to securing resources, could we see tensions rise in space? Will there be an arms race in orbit? So yeah, while the possibilities of space resource mining are exciting, the legal and ethical challenges are significant. As we continue to explore these new frontiers, we're going to have to figure out a way to make sure space remains a place that benefits all of humanity, and not just the few who can afford to reach it. So, let's take a moment and think big. We've been talking about space resources, technologies, the moon, Mars, and all the exciting developments that are happening. But what does all this mean for us here on Earth? How does this space gold rush change life for us down here? And what's the bigger picture for humanity's future? I mean, this is huge, right? A whole new frontier is opening up, and it's not just about getting rich off asteroids, it's about shaping the future of our entire species. First, let's talk about Earth's resource crisis. One of the most compelling reasons for looking to space is that our resources here on Earth are being stretched thin. We've got limited reserves of things like rare earth metals, oil, and fresh water. The Earth's population keeps growing, and with it, the demand for these resources is only going up. By 2100, Earth will likely face even more intense shortages of vital resources, especially as we tackle the challenges of climate change. So, space resources could be a lifeline. The ability to tap into things like asteroids full of platinum, water from the moon, and rare metals from Mars could help alleviate pressure on Earth's dwindling resources. Imagine being able to reduce mining on Earth, protect ecosystems, and preserve our environment, all because we've learned to extract what we need from space instead. That's a huge win for sustainability. And then there's energy. We all know the planet is in the middle of a major energy transition, trying to move away from fossil fuels and embrace clean, renewable energy. But even with all the wind, solar, and other clean tech we have now, there's still the issue of energy storage and supply. Here's where space comes in. Solar energy from space, specifically from solar satellites, could be a total game changer. These satellites would be able to capture the sun's energy and send it directly to Earth 24/7. Since space doesn't have the weather disruptions or day-night cycles that affect solar panels on Earth, this form of energy could be almost limitless. Not only could this change how we power our homes, but it could also help fuel space exploration itself, creating a kind of energy economy that's truly out of this world. But let's not forget about global cooperation. In the past, space was mostly the domain of superpowers like the US and Russia. But as more countries and private companies get involved in space exploration, the stage is being set for unprecedented international collaboration. Space mining is going to require a lot of cooperation. Countries and corporations will need to come together, share data, and possibly even collaborate on missions to extract and use resources. And as we see with the success of the International Space Station, international cooperation in space can lead to technological advancements, peace-building, and shared scientific discoveries. Space could be a unifier, showing us that despite our differences on Earth, we can still work together for the common good of humanity. Now, speaking of humanity's future, let's talk about becoming a multi-planetary species. One of the most profound shifts we'll see over the next century is the transition from Earth being our only home to becoming part of a cosmic family. Establishing self-sustaining colonies on Mars and beyond isn't just about saving ourselves from potential disasters like climate change or overpopulation. It's about ensuring the long-term survival of the human race. Imagine a world where humanity isn't just living on Earth but also thriving on the Moon, Mars, and even asteroids. Space resource mining could be the key to making that happen. If we can mine resources on Mars, build habitats, and generate energy locally, we can sustain life in ways that were once thought impossible. And this all starts with figuring out how to mine the resources that are out there. Then there's the economy, the economic transformation that comes with all this. Space resource mining won't just benefit a few rich corporations or governments. No, this is the beginning of a whole new space economy. By 2100, we could see space-based industries creating millions of jobs: mining, engineering, manufacturing, and even tourism. As we build out the infrastructure for space exploration and resource extraction, entire industries will emerge. Spaceports, mining operations, research facilities. They'll all need workers, and we're talking about high-paying, cutting-edge jobs that can't be done anywhere else. The rise of space commerce could also spark a whole new market for products and services we haven't even thought of yet. And that means new opportunities for people across the globe, not just the ones already living in spacefaring nations. And speaking of new opportunities, think about humanity's place in the cosmos. Right now, Earth is our home, but in the future we'll begin to see ourselves as part of something much bigger, part of an interplanetary civilization. Our curiosity about the stars, our drive to explore, and our need to adapt to new environments will propel us further into the universe. Space resource mining is just one piece of the puzzle that allows us to spread out and build a future among the stars. It's about making space accessible not just to scientists and astronauts but to people from all walks of life. And of course, there's the idea of space tourism. This is something that's already starting to take off in the 2020s, but by 2100 it could be commonplace. Imagine taking a vacation to a space hotel orbiting Earth, or visiting a colony on the Moon for a few weeks. Space tourism won't just be about luxury for the super wealthy. As the industry grows, it could become more accessible to regular people too. And when we start mining space resources, the infrastructure that supports these missions could provide jobs and growth opportunities for people on Earth, creating an entire economy that spans both our planet and outer space. Lastly, think about the technological progress this all drives. The innovations that come from space resource mining won't just stay in space. They'll flow back to Earth, changing industries and improving life here. The advanced materials, sustainable energy sources, and cutting-edge technologies that are developed for space will have huge benefits for us on Earth. From better solar panels to advanced robotics and AI systems, the leap forward in technology that comes from space exploration will revolutionize how we live on Earth. The tools and ideas we develop to survive in space will likely make life on Earth better too. So yeah, space resource mining isn't just about getting rich or reaching for the stars, it's about reshaping humanity's future. It's about ensuring that we have the resources, the technology, and the knowledge to thrive both on Earth and in space. And when you really think about it, that's the ultimate goal: to make humanity a spacefaring species, one that's no longer confined to a single planet but is reaching out to the stars to build a future that's sustainable, equitable, and limitless.